Hello students. So in this video we are going to see the arithmetic part, the outline. Okay, so this is under the module 4 arithmetic. So we are going to discuss about all the numbers and number system, what are the different techniques we are using to perform all the different operations. Okay, so here in the outline basically I have concentrated on these things. So the very first thing is what are numbers and what are the different operations we can perform. Okay, and the next one is addition and subtraction of signed numbers. Then the design of fast adder, it is otherwise called as carry locate adder also. And next multiplication operations. Then we have two different types of multiplication. One is unsigned number and another one is signed number. So unsigned is positive number and the signed number multiplication and fast multiplication. Finally we have the division part, then the floating point operations and the number system. So all these operations are performed by using the integer number. For floating point number operations we are having separate rules. So let us start with the number arithmetic operations and characters. Okay, so here actually we are using for all the operation, it can be a signed integer, it can be a positive number or a negative number, right? So here we are having the three different types of representations. So the very first representation is sign and magnitude representation, and the second one is ones complement representation, and then the twos complement representation. So these are the different representation, number representations are available. So let us see the very first one, sign and magnitude representation. By the name itself, it implies sign, then the magnitude, right? So here the sign plays a main role. See here in this particular diagram, here the positive numbers are from plus 0 to plus 7. Okay, so how we are defining all the positive numbers means by the sign 0. So here the magnitude of 0 is 0, 0, 0, and for plus 1 we are having 0 as a sign and 0, 0, 1 as a magnitude. For plus 2 it is 0, afterwards 0, 1, 0. So in this way we are writing from plus 0 to plus 7. For the negative number it is different. For the negative numbers the starting means the sign bit will be 1 and the magnitude are common. Okay, see 1 is the sign and 0, 0, 0. So this is the magnitude. So this magnitude is used for 0. Correct? So here it becomes minus 0. And 1 means it is 0, 0, 1 magnitude and the sign is 1. So this is considered as a minus 1. And for minus 2, 0, 1, 0 is the magnitude and 1 is the sign. That is for negative number. So minus 2. So in this way we are representing the sign and magnitude numbers. See for plus 4 and minus 4 only difference is the magnitude are same. 100 is the magnitude but the sign is 0 and 1. Okay, so here the higher order bit, if 0 means it is positive number or 1 means it is a negative number, and all the three lower order bits are mentioned for the magnitude. So that's why it is called a sign and magnitude, right? And next comes the ones complement representation. So what is the speciality of this ones complement representation means here all the subtraction will be implemented by addition and ones complement. Okay, but here if you see there are two representation of zeros, correct? So plus 0 as well as the minus 0. We are having the representation of 0 itself for positive as well as negative, right? And here what is called as ones complement representation means if the particular bit is, for example, see 0, 0, 0, 0, this is for plus 0. If we are changing all the ones into 0 and zeros into 1 means this is called as a ones complement, right? So here all the 4 zeros are there, this is called as plus 0. Then if I am making all this as a 1 means then it is considered for minus 0. Okay, and for plus 1 it is 00001, for minus 0 it is 1110. Okay, so this is the ones complement representation. For example, see 0, 1, 000. This is for plus 4. Plus 4 means here the sign bit will be 0 and the for negative number representation, the sign bit will be 1, right? And see this 100, the ones are replaced with the zeros, and the zeros are replaced with 1. Okay, so this kind of representation is called as a ones complement representation. But here we may face some sort of complexities in the addition, right? Because here we are having two different representation of zeros, right? So this causes some sort of problems. That's why we are going for the next representation. So the next representation is 2's complement representation, right? So for all the operations, we will be using the 2's complement representation only. So what is 2's complement representation? So here the main advantage is there is only one representation of 0, and we have one more additional negative number, one more negative number than the positive number we have. For example, see in the positive we have plus 0 to plus 7. In the negative, we are having minus 1 to minus 8. Okay, so this is called as a 2's complement representation. So here how to represent plus 4 and minus 4 means, for plus 4 it is 0 1 0 0, for minus 4 it is 1 1 0 0. Okay, so this is the representation. So this is the common representation which will be used for all the addition, subtraction, multiplication and division operations, right? And here the advantage is only one representation of 0 and one more negative number than the positive number. Okay, so here it will be like one's complement only, except shifted one bit position clockwise. Okay, so this is the one difference. And now we can see the binary signed integer representation by using all the different schemes. Okay, means all the different representation schemes. So the very first one is sign and magnitude. Okay, if it is 0 0 0 0, then it is plus 0. Then all the positive numbers, actually it is shown here. Okay, from here to upwards, and all the negative numbers from here to downwards, right? So this is the sign and magnitude. And here in one's complement we have the plus 0 as well as the minus 0. Okay, because of this reason only we are going for the 2's complement representation. If you see the 2's complement, plus 0 to plus 7 we are having all the number scheme, and minus 8 to minus 1 all the negative numbers we are having, right? So this is the standard representation for all the arithmetic operations, right? And now we are going to see the addition and subtraction of 2's complement numbers. So 4. So this is the addition. Okay, so now what we are going to do means we are going to add 4 with 3. So answer is 7, right? So this is manual calculation. In the binary format, 4 is nothing but 0 1 0 0 and 3 is nothing but 0 0 1 1, right? So if we are adding means 0 and 1 1, 0 plus 1 1, and 1 plus 0 1, and 0 plus 0 it will be 0, right? So this is the addition part, and this is the subtraction part, right? So if I subtract minus 4, okay, minus 4 means the numbers minus 4 and minus 3 is added, means I am supposed to get the answer as minus 7, right? So minus 4 is nothing but 1 1 0 0 and the minus 3 is 1 1 0 1, and we are going to add it. So adding is same way we can add 0 1 and 0 0 and 1 and 1. So 1 plus 1 means the sum will be 0 and the carry will be 1, that will be forwarded to the next level. So 1 1 1. So if we add 3 ones we will get 1 1 as a result, right? So minus 7 means it will be 1 0 0 1. And now we are going to subtract the amount, the value 4 with minus 3. 4 and 3, this is the subtraction operation, right? So 0 1 0 0 and 1 1 0 1. Minus 3 means it is 1 1 0 1. So what we will get means we are supposed to get the answer as 1, right? Whether we are getting 1, yeah, 0 and 1 1 0 0 0 1 1 0 and 1 1 it will be 1 0, right? So if you see all these different cases, actually here most common choice for integer number system within the digital systems, right? So this is the scheme actually we are making two's complement number, either we can add or subtract. Okay, so if carry in to the higher order bit is equal to carry out, then we have to ignore the carry. Okay, if the carry in differs from carry out, then it is considered as a overflow. Okay, if you see here, this is called as overflow. This case is overflow, and here also this case, this is considered as a overflow case, right? So now we are going to see the addition and subtraction of the sign numbers, means that the continued, it is continued. If we are going to add three different numbers like 0 0 0 0 0 1, means what is the sum and what is the carry, right? So we are writing it separately, for sum separately and carry separately. Okay, so if we write all the summation operations separately, means we will get xi, yi and c, right, plus xi, yi, c. See, what is si means, where and all we are getting sum as a 1. Okay, we are combining only those items here for si, and ci plus 1 is nothing but the carry. So where and all we are getting the carry, we are summarizing all the things here, all the functions together here, right? Yeah. So here the example is, see, 7 plus 6 means we will get 13 as an answer, right? But here what will happen means, there will be a carry. The carry will be forwarded to the next level, right? So that is called as carry in as well as the carry out operation. Okay, so this will be done by each and every stage of the addition and subtraction, right? Now, so what is the logic for the single stage of the addition, right? So here what will happen means, if we are adding x with y, means initially we will give carry as a 0, right? So x, y and c, for initially if we are adding, means we will get sum. Correct. So, and here by using this logic, we are going to get one full adder circuit. So, full adder circuit means here initially we are having the inputs called as x, y, and we are going to get one summation that is called as si, and after this addition, we will get ci plus 1, means the carry. Right, so this carry will be forwarded to the next level, right? So this is that's why this is called as the addition logic, right? And this is the n bit adder. So here n different numbers can be added by using the fast adder. So this is x, y, and here we are having the s0, means the summation for the first level, and the carry will be forwarded to the next level. So here it will be added by using this fast adder. Once again we will get the summation, then the carry will be forwarded to the next level, right? So this is the n bit adder logic. In the next video I will complete the carry look ahead adder, right? Yeah, thank you. I hope you have understood about the numbers and its operations. Thank you.